Okay, let's work on some of these, and it's going to look a little bit like those in some respects. Let's start a pattern, a strategy, if you will, of looking at the original problem and then doing this to it. If it is in exponential form, convert it to a log. If it's in logarithmic form, convert it to exponential form. That's what we're really going to start doing. So you can probably look at this first one and say the answer is 4. I agree with you. You're right. 2 to the 4th power gives me 16. You're right. You're not wrong. This one's -2. This one's, we'll deal with that. 1.5, I think. Yeah, we can do all kinds of fun stuff on those. But I want to show you the process that'll work even if you can't look at it and identify it. So let's grab a blue pen, whatever color you want to grab. And we're going to look at this and say, well, you know what? This is exponential form. Let's turn it from exponential to logarithmic, as long as you know where the numbers go, right? So log base 2 of 16 equals x. Well, lucky you, you just found out what x is, really. You just isolated the x. And it's 4, I know that, you know that, Desmos will tell you that, calculator will tell you that. If you're gonna use a calculator, I'm gonna press math and go down to option A, log base, and then press enter. And let's see, that'd be 2, and then 16. I will get a 4, just saying. Boom, 4. Again, you isolated x. We didn't know what that was. Well, you probably did. And we just found out what x is. There we go. So we're going to start with one form and turn it into the other. And this is exponential form. So turn it into a logarithm. Log base 7, okay, of 1 over 49. Now, I had said something in a previous video about how a logarithm is a fancy way of saying, okay, tell me the exponent. This is the representation that gives us that. So 7 to what power gives me 1 over 49? That's what this phrasing is. 7 to what power gives me 1/49th? And I blurted the answer a minute ago. It's -2. So 7 to the 2nd would give me 49, but 7 to the -2nd would take the 7 and put it in the denominator and then square it. So it's -2. And you can do the same thing here. By the way, if you're using a calculator, another shortcut to your shortcut, math, alpha, math. It's beautiful that way. 7 and then 1 over 49. And it is -2. So for this next one, we will start in exponential form because it is in exponential form. And let's rearrange. So log base 3 of 27 equals 2x. So we have that, and we're looking at that, and we're saying, man, I wish I knew what this was. Well, lucky us, we can figure it out. Actually, we can do this one in our head. 3 to what power gives me 27? Well, 3 to the 3rd power is 27. 3 times 3 is 9, times 3 is 27. So we have a 3 on this side. It's not that 3, it's a different 3. And if you need to see it, there we go, math alpha math, 3, 27, whoops, that's not it, that's too much. There we go, 3. Okay, at this point, we'll just simply divide by 2, and you get 3 halves. I like 3 halves. I'm gonna call it 1.5, however, which makes sense. If you plug the 1.5 right there, 1.5 times 2 would give you 3. 3 to the 3 is 27. Okay, sometimes it's not ready to go into logarithmic form. So we need to turn this truly into exponential form before we go any further. So step 1 is to divide by 3. That's going to give me 2 to the x equals, let's see, we'll divide that, and that gives me a 3, divide that, and we get that. So log base 2 of 32 is equal to x. This was exponential. It turns into a log. You can probably do this part in your head. You may not need to write all that, but this is a good process, good pattern to have. So 2 to what power gives me 32? It'd be a 5. I'll save you the trouble. X is equal to 5.